Okay, so hello and welcome back. So in this video we want to start another section of, a couple of videos talking about three-dimensional geometry. So basically what three-dimensional geometry is. What three-dimensional geometry is, so far we have been talking about only basically plane figures, meaning that we had this XY plane, and basically the XY plane was our basically XY coordinate system. We had the x-axis over here, we had the y-axis over here, and you can imagine that this is, for example, a completely flat piece of land. You have a completely flat piece of land, and on this piece of land there is absolutely no changes in your height. Absolutely no changes in your height when you walk across this land over here. So on this piece of land, on this imaginary piece of land, which of course does not exist in reality, on this piece of land you can basically keep walking from any place, any point to any other point. You can move from any point to any other point, and as you do so, there will be absolutely no change in your height, meaning that there is no points on this piece of land which is higher in altitude from any other point, and all the points have the exact same altitude. So if that is the case, if the altitude of every single point on this piece of land is the same, then we can just simply ignore the altitude of, for example, any kind of motion that happens on this piece of land, and then just simply think about going, for example, from left to right, or for example from top to the bottom. So that's basically, and you can call that, for example, two-dimensional let's call it movement, for example. In physics there are all kinds of words for this, but for now let's call it movement. And so far we have been doing the same thing, meaning that, for example, when we talked about, for example, a triangle, for example, we drew a triangle in the XY plane, for example, something like this, and this triangle is drawn in the XY plane, for example, the vertex A, vertex B, and vertex C. And this triangle, you can imagine that you have just simply a sheet of paper, completely flat sheet of paper, and you draw a triangle on your sheet of paper. It's a two-dimensional geometric figure, and that's basically all that it is. But we have also talked about solids. For example, we have talked about cylinders, we have talked about prisms, we have talked about rectangular prisms, we have talked about triangular prisms, we have talked about pentagonal prisms, and so on and so forth. So those kinds of solids, for example, suppose that you have a cylinder over here. Suppose that you have, for example, this cylinder over here. Now this cylinder is of course a 3D. It is a 3D shape. It is a 3D solid, and so this 3D solid takes up space, meaning that you need three-dimensional space for this. And so to represent this solid, then you would need, a two-dimensional coordinate system would not be enough. You would need a three-dimensional coordinate system, for example, something like this, and then your basically you could have another dimension over here. You could have another dimension over here, and that would basically be three-dimensional space, something like this. So this would be the y-axis. This would be the z-axis. This would be the z-axis, and this would be the x-axis, and this would be your origin. So now in this coordinate system, I have basically in the two-dimensional plane we had 4 quadrants. So we had basically this, the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So this was all that we had over here, and these were basically two-dimensional quadrants that we had in the two-dimensional plane over here. Now when it comes to the three-dimensional coordinate system, you have things like you have things called octants. So you have basically the first octant over here, which is basically, which you can imagine. Now this is not very easy to show it this way, but I can show it on here. So you can see that you have, for example, let's say that you have your x-axis over here, you have your y-axis over here, and you have your z-axis over here, and then you can see that you have the first octant right here. Behind that you will have, over here you have the second octant. Over here you have the third octant. Over here you have the fourth octant. Down here you have the fifth octant. Back here you have the sixth octant. Back here you have the seventh octant. And again down here you have the eighth octant. So this is a three-dimensional coordinate system. And as you can see, you have 3 planes over here. There is this green plane, which is the XY plane. There is this purple plane over here, which is the XZ plane. And there is this plane over here, this purple plane over here, which is the YZ plane. So then, and each of these parts over here, each of these basically parts in space, has been called an octant. And since there is, of course, 8 of them, so I suppose the name has been given to them because there is 8 of those parts, so each of them has been called an octant. And well, understanding three-dimensional space is of course necessary for working with vectors and working with all kinds of things, like working in meaning that almost every concept that you have in mathematics, you can have a three-dimensional representation of that concept, and then the three-dimensional version of that, you can do all kinds of things on the concept. You can do all kinds of basic operations on that concept using the higher level tools that we have in mathematics. For example, calculus is one of those higher level tools that we have in mathematics. You can take calculus, take it to for example 3 dimensions, take it to 4 dimensions, and using calculus then you will be able to work on all kinds of things, for example vectors, or basically solids in space, or three-dimensional everything in space. So that's basically the whole story here. Now, the first thing that we need to understand about, the first ingredient of the three-dimensional geometry is, of course, we need to understand the coordinate system that is used in three-dimensional geometry. And the coordinate system is just just some conventions that we have. So, for example, basically you need to understand how many octants you have, how they have been organized, what is the name of this plane, the name of that plane, what is basically how many, basically just a set of conventions. So let's start with this one, and then we will work our way through basically some. Of course, this part over here is just some very basics of three-dimensional geometry. I suppose in the next book we will learn more about three-dimensional everything in mathematics. So let's get started. Okay, so now in order to get to know in order to know more about the three-dimensional coordinate system, you do need to know a little bit about the two-dimensional coordinate system that you've been using so far. It so happens so often that basically, well, students or people use the two-dimensional coordinate system. For example, if I tell you that, for example, this is the two-dimensional coordinate system x and y. So for example, I tell you that I have this point 2, 5, and you're supposed to locate this point in this two-dimensional coordinate system. So then you would say, okay, so I move in this direction for basically 2 units in this direction and 5 units in this direction, and then this point is going to be basically 2, 5. And that would be right, of course, but as you can see, basically this point over here that you have plotted here, this point over here, is basically there is 2 units over here, and there is basically 5 units over here, 5 units of distance. So the 5 units of distance is the perpendicular distance of the point from the x-axis. So basically so that means that basically your y coordinate is actually nothing but the perpendicular distance of the point from the x-axis, and basically your x coordinate, which is 2, this is your x coordinate, and your x coordinate, which is 2, is the perpendicular distance of the point, from the y-axis, So then basically based on that, a coordinate system is just basically two lines, you could say two lines that are mutually perpendicular, meaning that the 2 lines are perpendicular to one another. And then you can basically imagine that, for example, you have basically right now, if you look at the ceiling of your room, if your room happens to be a normal room that is a rectangular room, the ceiling of your room can be thought of, and suppose that there is a lamp over here at the middle of the ceiling, for example. So you can specify or identify the position of this lamp with respect to the ceiling, meaning that you can imagine that you have this coordinate system over here, and basically you can say that I take this as 0, 0 or as the origin, and then if I take, for example, 1, 2, 3, 4, 5, 6 and 7 units over here away from this vertical axis, and then I go 1, 2, 3, 4, 5, for example 5 units from this horizontal axis, then I can say that basically I can say that I'm 7 units away from the perpendicular distance of the point is 7 units away from the vertical axis, and that will be my x coordinate, for example. I can define that as the x coordinate. So I can write that as x comma y, and my x becomes 7 and my y becomes, for example, the coordinate, the perpendicular distance of the point from the horizontal axis, which happens to be 5 units, and that would be basically the coordinates of the point in a 2D plane. Now it seems that the fire department is highly active today. They're having some sort of parade or something. Now suppose that now basically suppose that now I have the ceiling over here. I have the ceiling over here, and I'm looking at the ceiling from I'm sitting in the room looking up at the ceiling, and that's basically what I see. I see the ceiling as a rectangle and then a lamp over here. Now suppose that this lamp is just hanging in the air, connected to a piece of wire, for example, from the ceiling, coming out like 10 or 20 centimeters of wire, like for example 1 foot of wire or so, and then this lamp is hanging from that piece of wire. Now if I imagine that whole situation, I would be sitting in this room over here, which is a rectangle, which is a 3D shape. So I would be sitting in this room. I would be sitting in this room, for example, somewhere over here. I'm sitting somewhere over here, and the lamp is hanging from here. The lamp is hanging from here. So now using the 2D coordinate system that we had over here, I can take basically this upper face of the rectangle. I can take this upper face of the rectangle and express basically whatever it is that I see, express it in terms of a 2D basically coordinate system, and then say that, for example, the lamp is at a distance of, for example, so many units and so many units, and that would be my x and y coordinates in a 2D system. But now if I want to know basically what exactly the position of this lamp is in a 3D system, of course I will need a 3D system, meaning that I want to know basically how far is the lamp away from I want to know how far is the lamp away from this edge of the ceiling, how far away is the lamp from this edge of the ceiling, and also what is, for example, if I think of this as the lamp itself, how far is it from basically this base over here. Okay, how far is it from this base over here? So I want to have a way to express this distance, also this distance, and also this distance from the base or from the floor. So in this case, what I can do is that I can have I can define some axis over here, call it, for example, the y-axis. I can define some axis over here, call it, for example, the z-axis, and I can define some axis over here and call it, for example, the x-axis. Now I have 3 dimensions over here, and you can imagine that this is exactly this rectangle. If you just take this whole rectangle, it will fit into this. It will fit into this one. Well, I would call it, for example, one part of space. I would say a rectangular part of space, meaning that you could think of that as basically. You could think of that as this thing over here. So you see over here, you have the x-axis over here, you have the y-axis over here, and you have the z-axis over here. There is one plane over here which is vertical, a vertical plane. There is another plane over here which is vertical, and there is another plane down here, this green one, which is a horizontal plane. And what I drew over here, you could imagine that it's only, for example, this top part over here, that the space constraint between this pink part, this pink basically plane, and this violet plane, and this green plane. So this part over here, and it goes in all of these directions indefinitely, meaning that it goes in this direction to the top. So meaning that your y goes to infinity and your z goes to infinity, and your x, this axis over here, goes, basically keeps on going indefinitely. And this part of space I have represented using these 3 axes, which are of course mutually perpendicular. So this is also perpendicular to this one. That's probably the best way to show that. So this axis is perpendicular to this axis is perpendicular to this axis, and this axis is also perpendicular to this axis. Now I can put my lamp, for example, somewhere over here, and then say that, for example, this distance over here is, I can read it along the z-axis, and for example, and of course, but this is of course not a good way of representing this thing. I could, for example, I could put the lamp over here and say that, for example, the distance that the lamp has from this edge over here is, I can show it this way, for example. I can show this distance this way, and then this would be my this distance over here would be basically the y coordinate of the point. This distance over here would be the z coordinate of the point. This distance over here would be the z coordinate, and also the x coordinate of the point would be basically this distance over here. So that's basically, for example, that's basically how you can basically you can identify the location of this lamp in a 3D system. And this would be, for example, your lamp over here. So that's basically a simple overview of this whole story, and let's go and talk about a couple of these let's go and talk about a couple of these definitions over here, and then we will get to some exercises. So So usually when you draw a three-dimensional coordinate system, what you usually do, your z-axis is usually or at least what we are going to do in this book and also in the next book. Your z-axis is going to be a vertical axis over here. So this is going to be z and z prime. Z and z prime. Somewhere over here you have the origin or the center of the coordinate system, and this origin is the intersection of the z-axis with another axis which is called your x-axis. Your y-axis. And your y-axis, this will be your y, and this will be your y prime. And this point is going to be O, which is the center of your coordinate system. Now, you can have another axis over here, which can be thought of as the x-axis, and that would be, for example, x prime, for example. So what that means is that you can imagine that in the direction that everything is facing you have your x, and facing up you have your z, and facing to the right you have y, and in the other direction you would have y prime and x prime and z prime, meaning that going towards the bottom of the coordinate system you have z prime, going toward the left you have y prime, and going towards the back of the coordinate system you have x prime. And in this coordinate system, when you move to the right, you are moving in a positive direction. When you're moving to the top, you're moving in a positive direction. And when you're moving towards the front, you're moving in a positive direction. Otherwise, you're moving in a negative direction, meaning that moving towards the left, you're moving in a negative direction. Moving towards the back of the coordinate system, you're moving in a negative direction. And moving towards the bottom, you're moving in a negative direction. So that is that. And there is a couple of definitions that you need to be familiar with, and then we can move on to the next things. Okay, so now in order to basically, this system is basically something like this. So you have your axis basically over here. You have basically you have a plane over here, which is the YZ plane. So this is the y-axis and this is the z-axis, and there is a plane corresponding to these two axes put together. There is a plane corresponding to these two axes put together, and that plane looks something like this. They have a plane over here, and that plane looks something like this. That is the basically YZ plane. Now there is another plane. There is another plane which is basically the XY plane, and that is a horizontal plane, because the x-axis is a horizontal axis, and the y-axis is, of course, the intersection of the two axes becomes a horizontal plane, which we can basically show this way. Basically, we can show this way, and it goes over here and something like this and something like this. So that is that horizontal plane that corresponds to the x-axis and the basic intersection of the x-axis and the y-axis. So this is the xy plane. This is the xy plane. This plane over here is is basically the YZ plane. This is the YZ plane. And there is another plane that you have here, which is the so this is the YZ plane basically, and this is the XY plane, and the XZ plane would be the intersection of this plane, of the intersection of this axis, and the intersection of this axis and this axis over here. And as you can see, it's going to be a plane which is perpendicular to this plane and also perpendicular to this plane. And that plane I can show with basically this way, probably. So something like this, and then something like this, and then something like this. So this is now the XZ, this is the XZ plane. So now these planes, you can see them properly over here. So you can see that this is basically your x-axis. This axis over here is the x-axis. This axis over here is the y-axis, and this axis over here is the z-axis. Now, corresponding to the x-axis and the z-axis, you have this plane, this purple plane that you can see over here and goes to the back. Corresponding to the x-axis and to the y-axis, you have this plane with this horizontal plane over here, which is the green plane that goes all around the coordinate system. And corresponding to the y-axis and the z-axis, basically you will have this plane, which is, for example, you can say is perpendicular to the green plane over here, which is this purple plane, which is a vertical plane. So you have this vertical plane over here, you have this vertical plane over here, and then you have one horizontal plane over here, and basically 3 axes. So the 3 plane, and then you can say that these 3 planes are intersecting at the point O, intersecting at this point O, such that the 3 planes are mutually perpendicular to each other. And they intersect along these lines, along this line, along the line x prime O x, and along the line y prime O y, and along the line z prime O z, which are called the x, y, and z axes. And of course, you know that these lines are also, which are the axes, are also mutually perpendicular. These are also mutually perpendicular to each other, and they constitute the rectangular coordinate system. They constitute the rectangular coordinate system. The rectangular coordinate system. Now the planes, there are basically 3 planes over here, as we said before, that, and you can somehow, the planes can be called the XOY plane. So the XOY plane, the YOZ plane, something, and ZOX plane, So you have basically this plane over here, the ZOX plane, and so you have the ZOX plane, and then you have the YOZ plane, you have the YOZ plane. So YOZ plane would be this plane over here, which is the XY plane. That is the XY plane. And you also have the ZOX plane. ZOX I already wrote, and XOY plane. XOY plane would be the XOY plane would be the I think there is something wrong here in the notation. So basically you have the let me see, ZOX is basically this plane, which is the ZX plane. The ZX plane. The ZX plane. So you have the ZX plane, the Y, you have the ZX plane, or the XZ plane, you have the YX plane, and then you have the YZ plane that you can denote as, for example, ZOY. ZOY, that should be ZOY, and that would be the YZ plane. The YZ plane. Or you can let me see what let me write them down over here in the order that they have been written, and see if that's actually there is anything wrong with that. So you have the XOY plane, they have, and then they have the YOZ plane. They have written the YOZ plane, and then they have written the ZOX plane. And that is the first one has been called the XY plane. The second one has been called the YZ plane. The YZ plane, and the third one has been called the ZX plane. ZX plane, and let's see if that's actually correct. So XOY would be XOY, the YX plane. So the YX plane is actually the intersection of the Y-axis and the X and the exactly, yeah, that is right. That is actually right, because this is a horizontal plane, and of course you can imagine that there is a plane basically exactly horizontal on these axes, and this is a horizontal axis, this is a horizontal axis, so there will be the XY plane exactly horizontally on these two planes, on the X-axis and on the Y-axis. And then there is the YOZ plane, which is basically this plane over here, which is which is basically YOZ, which is the YZ plane, which is also correct. And the ZOX plane, the ZOX plane is basically this plane over here, which is a vertical plane, which is the XZ plane, which is exactly this thing over here. So these are known as the three coordinate planes, known as the three coordinate planes, the three coordinate planes. And well, we take the XOY plane, or the XY plane, this plane over here, which is a horizontal plane over here, this one, we take that as the plane of the paper. We take this as the plane of the paper, meaning that you can imagine that this is just a horizontal sheet of paper or something like that. Now we will know more what they mean by the plane of the paper. And the line Z prime OZ as perpendicular to the plane XOY. And the line Z prime OZ. So Z prime OZ is of course this axis over here, which is perpendicular to that plane. If the plane of the paper is considered as horizontal, so of course you can consider this as horizontal. If the plane of the paper is considered as horizontal, then the line Z prime OZ, which is the Z axis, will be vertical. So this would be horizontal, and this axis would be vertical. So the distances measured from XY plane upwards in the direction of OZ are taken as positive, and those measured downwards in the direction of OZ prime are taken as negative. So what that means is that this XY plane that we had, you can see it better over here, which is this green plane over here. This is the x-axis. You can see that it's a horizontal axis. So of course I can move this around. I can move this as in any way that I want, and then everything changes, meaning that horizontal becomes vertical, vertical becomes horizontal. But you need to learn this in just a fixed way, in just a particular way, and preferably in the way that we are basically laying everything down right now. And then based on that particular way that you learn the system, then you will be able to use it. Otherwise, if you want to think about moving things around in space and that sort of thing, you will actually confuse yourself. So what you want to imagine is that basically you can consider this whole thing as space, as the whole space that you can imagine, because all of these planes can go indefinitely in every direction, to the top, to the right, to the bottom, to the left, and so on and so forth, to the back and to the front. So there are really no limits here. Now, you can imagine that the space, the imaginable space that you can imagine and see, is just basically divided into 8 parts over here. You have basically 1 part over here, you have 1 part over here, one part down here, 1 part over here, and you get the exact replica of this on the back. On the back you will have the exact same thing. So what this system does, it just takes the whole space that you can imagine, and then it kind of divides the whole space using these three, basically using these three planes, using these 3 mutually perpendicular planes, into 8 basically 8 parts called octants. Each part is called an octant. Now, and the way that you can learn this is that you can imagine that basically if you're looking into space, or of course you couldn't be looking into space, you would be a part of space anyway. But the space that you're a part of is basically, you can imagine that the x-axis is the axis that is going into the depth of space that you're looking into, and or probably a part of. And then this y-axis is running across the space that you're imagining. And the z-axis, which is perpendicular to both of these axes, is just running through the space from top to the bottom, and then as a result you would get these 8 octants, and that's basically the whole story. Now, in this system, you will get this horizontal plane, this green one, this green plane over here, which is called the XY plane because it goes through the x-axis and also through the y-axis. Now, as a convention, we basically define all distances, not distances of course, but the coordinate or all the z coordinates of every point, which is to the top of this plane as a positive coordinate, as a positive z coordinate, and all z coordinates to the bottom of this, green plane over here as a negative z coordinate. So that's basically what we read over here. And moreover, basically we, as some sort of convention or agreement between ourselves, so that we don't confuse ourselves and so that we can talk about something, talk about the location of a point, and so that everybody understands what everybody else is saying and meaning. So the distance measured to the right of the zx plane, this is a zx plane, this plane over here, which is like an orangish color. So all the distances measured to the right of the zx plane along OY are taken as positive, and to the left of the zx plane along OY prime, this point over here is y prime, which is not present here, along OY prime as negative. Now in front of the YZ plane, which is basically this violet plane over here, and it is across the y-axis and the z-axis, in front of the YZ plane along the OX as positive. So if you take this plane over here as the YZ plane, then basically there are two axes going through this plane. Actually one axis, but then it goes through the origin, and you can imagine that there is one axis going out and one axis coming in towards you. So in front of the YZ plane along the line OX, every basically distance is taken as a positive distance, and when from this point going to the back, every distance is taken as a negative distance. So that's basically and you can see that, for example, over here you have -5, -10, and over here you have 5 and 10. So that's basically how the system basically works. And the point O is basically called the point O, which is right over here at the point of intersection of the three axes and the point of intersection of the three planes, is called the origin of the coordinate system. That is called the origin of the coordinate system. The three coordinate planes divide the space. These three coordinate planes divide space into 8 parts known as octants. And these octants are basically, you can see 4 of them right here, 1, 2, 3, 4. And 4 of them you can see down here, 1, 2, 3, and 4. So there are 8. Let me put this over here so we can see what we are doing here. So there are these parts over here which are called octants. And these octants you can simply call them, for example, you can call them as if I come over here, I can show you this image over here, this diagram. And these octants you can call them as, for example, XOYZ. So XOYZ, that would be basically this octant up here in the front, So XOYZ would be XOYZ would be the first octant. It's called the first octant. It's called the first octant. The next one, the next octant is basically the octant to the back of that octant, meaning that you can see that right here there is an octant, and to the back of that there is an octant. And what I mean is now the octant to the back of the first octant, and that you can identify as X prime OYZ, X prime OYZ. So you can identify that as X prime OYZ, which is basically called the second octant. The second octant. And then you have to move in a counterclockwise direction to get to the third octant and to get to the fourth octant, meaning that right here this was the first octant, this was the second octant. Now looking from the top, this is the first octant, this is the second, the third, and the fourth. So the third octant would be X prime O Y prime Z. X prime O Y prime Z. And that would be the third octant. X prime O Y prime Z. The fourth octant is basically this one over here, right in the front, and that you can identify as XO Y prime Z, XO Y prime Z, and that is XO Y prime Z, and that is the fourth. That is called the fourth octant. Now, in order to get to the fifth octant, you need to go down, and then you need to start from where you started in the beginning. So, in the beginning with the first octant, we started with this octant up here. So, the fifth octant is exactly below the fourth octant. So, I'm sorry, below the first octant. So, the fifth octant, you can start down here. This would be the fifth octant. And so I can identify that octant as basically it's down here. So it's basically below this basically below this plane over here, this part over here, which is XOYZ prime, XOYZ prime, and that is the fifth octant. That is the fifth octant. So the fifth octant is XOYZ prime. And again, you need to move in a counterclockwise direction, meaning that if you imagine that this is the fifth octant in the front, in the back would be the sixth octant, and the back would be over here, which is X prime OYZ prime. X prime OYZ prime is the sixth octant. Is the sixth octant. The seventh octant would be basically, so this was 5, this was 6, and this is 7, meaning that now let me find my axis over here. So basically down here was the fifth octant, and then this would be 6th, 7th, and 8th. You see over here, this is the front, and if I move this up over here, so this would be 5, 6, 7, and 8. So that means that then 7 would be 5, 6, and 7 would be right here, down here at the back, which is X prime, or basically O Y prime Z. X prime O Y prime Z, that would be the seventh octant. That would be the seventh octant. and the 8th octant is just then coming in a counterclockwise direction, or basically going, I don't know how to say that really, but going in this direction, in a circular direction from X to Y to the back and forth and back to where you started. The 8th octant would be this, basically this octant down here in the front, which is basically X, O, Y prime, Z prime. X, O, Y prime, and Z prime. That is the 8th octant. X, O, Y prime, Z prime. That is basically the whole story here. Now there is one more part that we need to discuss here as far as the theory is concerned, and then we will get to the rest of the things. But I'm going to end this video here, and then we will continue in the next video. I'll see you in the next video.